Right. Thank you so much for joining us on this webinar today for Testia's thickness tool. My name's Matthew Day, Technical Sales Manager for the UK, and we're going to be talking about reducing costs associated with thickness measurement after blending for wing and fuselage inspection. Okay, so where do we begin? We'll start in the current state of affairs. So the current approach for thickness measurement after blending. What are the contributing factors that lead us to have to perform thickness measurements? So heat and sand, ice, water, and heat or fire. All of these can lead to corrosion and scratches being developed over the life cycle of the aircraft. The consequence of these contributing factors is that technicians will sometimes have to blend out large areas. And then the current approach, or traditionally, the NDT inspector will have to measure the remaining thickness of the part, usually by filling out a grid. For Airbus and the NTM, it's by filling out a 10 by 10 millimeter grid. And this process can take a very long time. So for an area of 200 millimeters by 200 millimeters, requires 400 measurement points. Usually, this process is a two-person approach. And if we make the assumption that each measurement takes 20 seconds to record, take, and write down, we're looking at a total of over 8,000 seconds for one grid measurement, 2.2 hours, quite often for two people. There are the risks of mistakes, and this is a very low added value for the expert's time. So this is why Testia created the thickness tool, which divides the inspection time by 20. So a brief history into the thickness tool. A new approach. 2015, the thickness tool, abbreviated here to TT, was validated with a thickness range of 5 to 20 millimeters, and it first appeared in the NTM 511004 procedure B. By the end of the year in 2015, we had improved the thickness tool range, extending it down to 2 millimeters. And later this year, with the advent of the thickness tool Neo, that will be increased to 0.6 millimeters, up to 20 millimeters. So the hardware shares a similar platform to our conventional UT and eddy current system. So the front end is pretty much the same. It's portable, lightweight, battery operated. It's rugged, tough book. 10.1-inch touchscreen, water resistant, full connectivity. It's modular, which means that we can add and remove software, and it's compatible with our remote assistance, which we have another webinar for same time next week. So if we take a look at the context and challenges. So thickness measurement after blend out is mandatory, stipulated by not only the manufacturer, but also by the airline operators. This takes a lot of time, and by consequence, there's a lot of money lost in the activity. Often, the inspection will have to be performed by two people, which increases the risk of dual entries and errors due to human factors. The classic inspection process is not repeatable because of the positioning of the point-to-point grid may vary. Also, hand pressure may change, and coupling can vary too. Agility in both manufacturing and maintenance is compromised due to the complexity of the acquisition process. All of this contributes and results into delays, expenses, and efficiency losses. Excuse me. So, what are the solutions and what are the benefits? So if we take a look at, we can perform inspections on large areas 20 times faster than the current approach on fuselage and wing inspection. We avoid dual entries and human errors thanks to automated reporting capabilities. The system is fully digital, continuity from acquisition to reporting, and what that means is that it's a completely digital process. So once we start the inspection through to reporting, there's no other sort of contributing factors required. And it's referenced in the Airbus NTM 5110-04 Procedure B. So it's already a validated inspection process. If we look at the thickness tool in a bit more detail, it's powered by Testia's NDT kit UT. We had a webinar on this last week, which will soon be available to watch again on YouTube. And NDT Kit UT is an automated defect recognition software. So it takes a lot of the repeatable processes and automates it for the user. We can operate in metric or imperial. Assisted velocity calibration process. The velocity calibration process is very easy to manage, and the resulting screen is that we can see A scan, time of flight, C scan, and E scan displays as well. Excel grid measurements are automatically generated, given a 10 by 10 millimeter representation, and also a Word report is generated. The Word report is Microsoft Office, an accepted format, well-known format, easy to use, and is used internationally. So there's no specific training for the post acquisition reporting. We can highlight values below a specific thickness, and that's free for the user that's free for the operator to use. And we have the ability to add an image into the report using the onboard camera from the thickness tool itself. A brick for inspection 4.0. So what does that mean? The thickness tool kills the thickness mapping processing time. It absolutely destroys it. So Inspection 4.0 or Industry 4.0, it's all about the digitalization of processes, the repeatability of processes. And that's where the thickness tool really stands out. So when we come from corrosion or impact to blend out, where then the thickness tool really comes into its own with the locating, the sizing, and the reporting. Because the reporting is done on the instrument, it can be sent directly from the instrument using the connectivity on board. This can either be sent to Airbus 3D repair, or it can be sent into your own ERP system, depending how you're working. So, if we take a look at the thickness tool itself, I would love to have done this live for you, but unfortunately, due to social distancing at this time, I'm using a video that was recorded previously. Okay. So what we can see now is that we are, my colleague here has completed the setup and he's running through a scanned part that has 3 blended out areas. He has had already provided for him the measurements, the grid measurements in columns and rows, and all he's had to do is measure out a 45 millimeter wide guidelines, which the onboard laser lines track and allow you to follow neatly. And we can see very quickly, very easily, that we've been able to scan a very large area in a matter of seconds. We can see the 3 correlating defects, their blended out areas to the screen. Okay, so once we've done the inspection, what do we get? So we get 2 files. We get an Excel report, which is gives us the thickness readings for every 10 by 10 millimeter grid. And we can specify a thickness criteria. So it will highlight those areas. And we can see here down in the bottom right-hand corner, we have a red area. On board the instrument, we do get full use of Excel, which include conditional formatting, and that's available on board the instrument as well. And we also get a Word report. So the Word report is a predefined template. So the reason why it's a predefined template is so that the system can automatically populate and generate specific areas within the report, which we'll see very soon. It's a free text boxes. So in here we have my company. This can be preloaded with your own company's logo. An inspection report is identified. Date is preloaded, and also page numbers. Our reference, your reference, and for the attention of, written by and approved by, are all free text box for the operator to use. The next page, it comes pre-populated with the equipment, but because this is Word, free text boxes, we can input our serial number, we can input date of expiry of calibration, we can edit, although it is already put in for you, we can edit the procedure referenced, what the description of that procedure was, what's the latest issue, and the date of issue of that procedure. So again, this is all something that's pre-populated for you. Within the report, we have the opportunity to input a photo. The photo is taken using the onboard camera from the instrument itself, from the thickness tool, and it will, and then we can input it just like a normal Word format, the image here, and this gives us details of the inspected area. Provided within the thickness tool kit is an acetate sheet, and the acetate sheet has the grid measurement already printed on it. It's see-through, it's clear, so we can put it over the inspected area, and that way we get a photographic area with the grid measurement without having to measure it out and plot it by hand, which again is a very time and laborious activity. We also get our C-scan results automatically imported. So each dot on the C-scan that you see on the image on the left-hand side represents the 10 by 10 millimeter squares. It's very visually impacting, and more importantly, it's easy for both the skilled and the layman to interpret. You can see very clearly that we have 3 areas of interest on the scanned area that we have. And that, coupled with our photograph here, gives a nice visual representation of where these defects are. So not only do we get a C-scan image on our Word report and a photo, we also get the Excel grid automatically populated into the report. And again, the numerical values represent the 10 by 10 measurement points, 10 by 10 measurement grid, should I say. And the rows and columns will match the acetate sheets for easy referencing backwards and forwards. So very recently, over the last year, Testia have been working alongside Lufthansa Technik to refine our processes in a very demanding environment. So what we were able to achieve, and what Lufthansa were able to achieve, should I say, is they were able to set up a comparison between the traditional, the current method of measurement after blending against the thickness tool that they own. So the case study. Lufthansa were investing in new technology. So they were looking far and wide for technology that would speed up workflow throughput through their facilities. The thickness tool was identified quite early on as pivotal to reducing time spent on MRO activities. Within a large MRO base, like at Lufthansa, at their different bases, plotting grid measurements, measuring, reporting is a very time-consuming activity. So they were really keen to find a tool that that could reduce this for them, and consequently, with feedback from Lufthansa, they were instrumental in the current and future developments of the thickness tool. Okay, so what did they do? So they were measuring an area and timed both systems, so both the current method and the thickness tool from scratch, and inspections were performed consecutively. For the traditional method of inspection, they recorded a time of 300 minutes with two people, two engineers. This is again from switching these sets on, forming calibrations, setting up the grid measurement, recording the measurements, and then conducting the reporting after it. In comparison with the thickness tool, it took one person 26 minutes from start to finish. That's switching the instrument on, performing the calibration, setting up the measurement lines at 45 millimeters apart, and scanning, and then generating the report after it. So, what results did they see? On the top left-hand side, the grid measurement there, this was the area that they were most interested in. This is what they were looking for. And unbeknown to them, the thickness tool was able to identify very easily, very quickly, the two spots on the left-hand side, the far left and the middle one. Because the scan area was so much larger, they were able to cover it very quickly, and they were able to identify it very quickly. By comparison, on the left-hand side is their image that they took, and then on the right-hand side, you can see the corrosion detected on underside of the wing of the top skin panel on the trailing edge. So both these areas were unknown at the point of inspection. They were only looking at the blend out on the right-hand side. One of the developments that Lufthansa Technik has suggested to us, and one that we will be implementing, is the grid overlay onto a C-scan. So a nice feature is that we currently have the opportunity for an image, a C-scan grid, like on the bottom right-hand side, and then the Excel on the top left. And what the feedback from Lufthansa is that if we can merge the Excel grid files and the C-scan image, that will provide another level of understanding for the observer, for the viewer. All of this, during this process, it was calculated that Lufthansa increased their efficiency by 91.33%, which is amazing. It's jaw-droppingly amazing that one piece of kit can increase efficiency to such a level. Okay, so we elaborated at the beginning that at the end of 2020, we're going to see the release of the thickness tool Neo. The current version is called the Max, and with the Neo, we're having new cards, new data cards, and what this allows us to do is to reduce the thickness that we're measuring down to from 2 millimeters down to 0.6 millimeters as well. It will be lighter, over a kilogram lighter. The photo taken you'll be able to take the photo directly from the report itself. So rather than taking a picture, saving the file, and then importing it as an image, as a JPEG, the report will be able to do it more automatically. C-scan and image blending, as I've said, and detection and sizing of corroded areas. Now, this is currently in development, but it will be, the software is more than capable of looking at it. So not only will the thickness tool be able to be used for post blend out, but we'll also be able to use the thickness for corrosion detection and mapping of an area, which makes the thickness tool far more diverse piece of equipment to use. We are experimenting with the opportunity to make this used as for non-skilled, non-trained, should I say, non-trained NDT personnel, and that will come in time. Because there's the presence of an A scan on the instrument, that means that we have to. This is only certified for use by NDT trained personnel, but hopefully with time and as the NDT kit UT software that runs the thickness tool is developed, we'll be able to utilize people who have not sat NDT official training will be able to use the thickness tool as well. Okay, so if we can take a moment to, this is a very busy screen, I'm sorry for this, but if we can take a moment to have a look at a typical business case. So some conservative assessments were made. We made the assumption that man-hour rate is $60 per hour. $10,000 aircraft lease rate per day. Again, it's quite conservative, and 2 inspectors to perform the current or the traditional task. Return in service for those aircraft is delayed due to this 25% of the time. Okay, so a quarter of blend out inspections will result in that aircraft being delayed for release. Typical delay is between 1 and 15 days. Again, conservative average is 3 days. When the aircraft has corrosion or big scratches, we can assume about 15 of them for an average of 200 by 200 millimeters zone. Now, not all of the areas will be that of that size. Some will be larger, and at least one aircraft subject to it per month on average. So again, we're looking at 12 inspections per year, and an inspection for 200 by 200 zone taking on average 2 hours for 2 people, as proved very recently by the Lufthansa Technik case and with previous experience. So if we look at a 1 year before the thickness tool, we're looking at 30 inspections per month, which results in 120 hours, $7,200 cost per month. If we add in 3 days cost for delay, 25% of the impacted aircraft, which is 12 per year, or 9 days, that has a result, in fact, of $90,000 to the industry, resulting in a cost of $176,400 per year. So if we take the same information using the same conservative assumptions and look at a 1 year period with the thickness tool, the initial investment, $80,000, so that's for the equipment. The initial training to use it, it's 2 people 1 day, can easily cover it at $1,500, not including travel and other expenses for the trainer. Looking at the cost of 30 inspections per month with time divided by 10, again, quite conservative. We state 20, but for the sake of the business calculation, it will be a very conservative 10 times. That's looking at a cost of $720 per month. There's no delays impacted by this measurement because of the reduced inspection times, resulting in a cost of £91,000 or 91,000 US dollars. A few things that we didn't calculate, including the calculation, is hanger slots, reactivity to other emergencies. Those items will generate more savings. But based on versing the current traditional method against using the thickness tool, you'd be looking at saving around about 85,000 US dollars per year, which is a considerable saving, almost the initial investment savings, which means that the second year you'll make those savings again. Okay, so to conclude, it has been trialed and tested, and on repeat, we see that there are that the instrument, the thickness tool, is 20 times faster than the traditional thickness measurement after blending process. So, consequence of that is that efficiency is increased. It is all run off a very powerful Windows-based tablet. So the benefit of it being a Windows-based tablet is that you can it uses a format that everybody is very familiar with. Microsoft Office packages, etc. File formatting. One engineer required rather than two. It goes without saying that NDT engineers are experts. They are very talented and very experienced. This is a very laborious process that requires an awful lot of attention for a very long period of time. So it's much better to use fewer resources, reduce the time that you're inspecting, and be able to put your NDT inspectors to far more complex work. The onboard reporting requires no special formats at all. And the kit, when you buy it, contains everything you need for the inspection. So, what are the USPs for the thickness tool? So grid measurements meet the NTM standards. It's already specified in Airbus TMs. The reporting format is completely editable on board the equipment. It's easy to use. The easy walkthrough, calibration setup, and remote assistance. So we do have a webinar again next week regarding remote assistance, where I'll be demonstrating on our other smart tool, the Smart UE1, how not only can users see the screen, see the results live, but they can also see the cameras. You can also use the camera so they can see what the people are looking at as well. So more on that next week. It ensures the correct working procedure is followed. So the operator must follow the calibration process on the calibrated step blocks. They must do this every time, so that ensures that the operator or the owner of the aircraft is confident that the process has been done every single time and it is done correctly. It's designed by aerospace for aerospace. The thickness tool is the only phased array tool that is designed with aerospace in mind. All of the other offerings on the market today from the other OEMs are designed to fit in with oil and gas, rail, power generation, and aerospace. So we have Microsoft Office software. It's easy for everybody to use. And again, all of the other manufacturers, they have their own formatting that makes them unique, that's unique to themselves. And of course, the thickness tool has full connectivity, so 4G and Wi-Fi. Okay, so the competition. Nearly all of them will export phased array grid measure C-scan measurements into Excel. Usually, the grid measurement is a 1 millimeter by 1 millimeter. It's too much information. It's too much information for the recipient of the reports, and it's too much information for the NTM. Sometimes too much information is not a good thing. Onboard reporting can lack customization, so we can reports can be generated on competitive equipment, but there is a lot of features on there that can't be edited. Probe and equipment are not specifically designed for aerospace. As I've said, you may have probes that are specifically designed for composite. You may have probes that are specifically designed for oil and gas. And all of the components within the thickness tool have gone through a very strict and stringent validation process. So we're through Airbus. So we are using all of the parts that have come from separate validation processes and combining it into one instrument. Quite often, you cannot add a photo of an area from the instrument. It requires taking an image on something else and added it into the report later, post-processing on a separate PC. So even though you get you get the equal amount of benefits of speed for inspection, you're still having to do the reports later on. The OEMs of competitive equipment, their formatting is unique to them. Again, it's their USP. It's what makes them stand out from the rest. Consequence of this is that they all need learning and familiarization by the operator. So, last slide, I promise. Thank you everyone for your patience so far. The thickness tool is the start of an investment. So as I said, we are already developing other features for the thickness tool Neo. So it's an evolving tool. New applications and features are added year on year. So really, you're buying for the future. You'll see payback of the investment within the first year. Less so if you have even larger inspection areas and more frequent inspection areas than once a month. But then it's a huge cost-saving exercise and tool. So if we're looking to see what the investment is on the equipment, the total price of the thickness tool, this includes all of the accessories and ancillary items to make sure it all works, is 70,000 euros. So big investment for even bigger savings. So thank you very much for your time. I hope you found it enlightening. Testia are interested in hearing from companies outside of aerospace, where we are a aerospace-centric company, but a lot of our tools, not just the thickness tool, but a lot of our tools can be developed further into other markets. So we're very interested in hearing from other markets to aid our diversification. For the thickness tool, demonstrations are more than welcome, and also trial weeks are available. So please contact myself at my email, matthew.day@airbus.com, and we'll be more than happy to organise it. If you're in the UK, it'll be myself. If you're not in the UK, you're elsewhere, then I will pass your contact details on to one of my colleagues that will represent your area. So thank you very much. Now, if we have some questions, we'll take the time to go through some questions. Okay, so we've got one question here about single element tap off. So at the moment, no. The NTM that the thickness tool was written around, thickness after bending, doesn't have the requirement for single element tap off. This is so that you can use say a delay line crystal probe along with the instrument. It is something that we're looking at. We know it's used in other industries. So the thickness tool, if you take away the software for the thickness tool and use it just as a phased array instrument, it's a 32 element, 32 module, and it's something that we know will need looking at. So definitely that's something that's coming in the future and will be much more accessible in the Neo. So probably later on in 2020 or more likely in 2021. So how about using? Okay, so we've got on composite areas. So yes, so the thickness tool is originally designed for metallic aluminiums, the two types that you find on airframe and fuselage and wing. For composite areas, as I understand it, I'll have to check. It's a case of rewriting a small amount of code within the automatic defect recognition software NDT kit UT to be able to recognize those different velocities. But yes, the hardware is there. The software will need a small amount of tweaking. The thickness tool, so the roller probe and the U32 is actually used on another product line that we have called Line View. The Line View is a C-scan system for composites, but more specifically, it's designed to be used by non-NDT trained engineers. So it's definitely something that we'll be looking at to combine in the future. Probe. Right, okay, so one about the probe. At the moment, the probe that we use is a 5 megahertz GE roller probe. We up to date, we haven't developed our own roller probe as yet. I alluded to earlier in the presentation that all of the equipment that goes into making the thickness tool has gone through a validation process. So the roller probe in its own right would have gone through its own validation process against all the other manufacturers, and it was determined to be the best because it's not a water-based roller probe. The signal between the signal transmitted between the roller itself and the part is far better, far cleaner, far crisper. So even with a 5 megahertz 32 element probe, we can still get down to 0.6 millimeters of thin sheet aluminium, something that other water-based roller probes find very difficult to do. But again, this brings us back to not all NDT equipment is fit for purpose for a specific job. Other roller probe manufacturers are primarily designing for oil and gas, which has very thick steel products or titanium products or Inconel products. So being able to measure down to less than 1 millimeter is less of a problem, is less of an issue for them. Okay. All the questions that we have. Thank you very much. We're slightly ahead of schedule, but that's okay. Better to be ahead than late, I think. So thank you very much for your time. I'll over the next couple of days, I'll be able to send out the presentation and our company presentation as well. And again, once again, thank you very much for joining. Very much appreciated, and I look forward to seeing you all again very soon. Thank you.